In this video, we'll discuss a tricky problem from voltage regulator circuit. There's a high chance that student will make mistake to solve that problem. Let us start. This is the circuit, very simple circuit. One 10 volt source, one 1K resistance here, one 1K resistance here. This is the load, and we have one Zener diode. And it is mentioned that Zener diode, its voltage, Zener voltage is 6 volt. So we need to find out the output voltage V0 here. You know that Zener diode is used to get a regularized voltage output. So if it is working under breakdown region, then Zener voltage will appear as 6 volt. So you may think that the output voltage will be 6 volt because this load is directly connected across this Zener diode. So if it is 6 volt, it could be 6 volt. Okay, but this answer is wrong. We need to explain this circuit correctly. Okay, so let us start. So what we'll do, first we'll assume that, okay, this Zener diode will be in breakdown region. This is our assumption. We'll start. Okay, so once we'll assume this Zener diode is in breakdown region, then, so this is the Zener diode. So its voltage is Vz equals to 6 volt. Its breakdown voltage or Zener voltage is 6 volt. Then it will provide constant voltage across the Zener diode 6 volt. That we can start with. So with this voltage, so this voltage is fixed. Whatever current is flowing across this Zener diode doesn't matter, but voltage across the Zener diode is 6 volt. So with this concept, we'll analyze the entire circuit, and then again at the end, we'll recheck our assumption. We'll see that what is the current flow across through the Zener diode. So this current from N to P, this side current IZ, if this is non-zero, more than 0, it is positive, then only it is under breakdown region. Otherwise, it won't be in breakdown region, because Zener diode should be in reverse biased condition. So current should flow from N to P, not P to N. If current is flowing from P to N, obviously it will be forward biased. So it need to be in breakdown region, means reverse biased. So once you will assume that it is in breakdown region, obviously it is in reverse biased. So current should be in this direction. But at the end, if we find that current is opposite direction, that means our assumption is wrong. It is not in breakdown region. It may not be in forward biased, but not in breakdown region. Right? So our assumption was it is in breakdown region. So this is the way we'll check. And once it is not in breakdown region, then if I know that it is in reverse bias condition, then diode will not work. Then current through the diode will be 0. Then again we should analyze the circuit and we should get the output. Okay. So let us see this problem. We'll consider these things, right? That this is a Zener diode. So this current is IZ, and this is your 6 volt. Now what we will consider? I'll consider this is grounded. So with respect to this ground, this potential is 6 volt. This node is having 10 volt, and this is your V0. Okay, and this is one junction, and there we can apply KCL, Kirchhoff's current law. So this current is suppose I1, this current is load current IL. So obviously the supply current I1 by the source should be equals to IZ plus IL. Now I1 easily we can find out because 10 minus 6 by 1K. And this IL also we can find out because 6 minus 0 by 1K. So we can replace I1 and IL here. So I have replaced these things. This is your I1, this is IL. I can find IZ. And IZ is giving you 10 minus 6 is 4, and this is 6. So 4 minus 6 by 10 to the power 3 means minus 2 times 10 to the power minus 3 ampere, means minus 2 milliampere. So this negative sign indicates that this current is negative, means current is not flowing, cannot flow in this direction. It should be in this direction from P to N. So this signifies our assumption is wrong. Means this diode cannot be in breakdown region. And you see that this potential is higher potential, positive potential compared to this one. So of course this diode will be in reverse bias region, but not in breakdown region. It won't get sufficient potential. That's how it won't be in breakdown region. So once it is not in breakdown region but in reverse bias condition, that time this diode will not work and current through diode will be 0. So I'll consider it is off, diode is off, and current is 0. And as current is 0 through the diode, we can remove the diode from circuit simply, because we need to find out the output potential. We'll remove this diode. Then what we'll get? We'll get only 10 volt source here 1K, and this 1K load. We can find out this potential across this one because no current is flowing. Now this is very simple circuit. It's a potential divider circuit, 1 kilo ohm, 1 kilo ohm. So obviously this output voltage will be this resistance upon total resistance. So 1 upon 1 plus 1 into 10, actually 1K upon 1K plus 1K equals to 5 volt. So it is equally divided. 10 volt is equally divided, it's 5 volt. Okay. So your answer V0 is 5 volt, not 6 volt. Don't make this mistake. So whenever you will get one Zener diode, even if it is ideal, first assume that it is in breakdown region, then analyze the circuit, then again at the end recheck your assumption. If assumption is correct, that is the answer. Otherwise, if you think that Zener diode will be in reverse biased but not in breakdown region, IZ will be 0. Okay, and then again analyze the rest circuit and find the output. Okay, so if you have enjoyed this video, please press the like button to encourage me to make more videos. And if you have not subscribed this channel, you may subscribe the channel. I'll be uploading lots of videos in this channel. And if you have any suggestion to make certain problems from other subjects like EM theory, communication, digital logic design, okay, you may suggest this one. I'll try to make videos from those topics. So thanks for watching.